Hello everyone. Today we are going to continue from the previous question which actually took the input from a potentiometer and displayed the input onto a serial monitor, onto the serial monitor. Today we are going to do a little more from that. So that is why I have left my system as it is. So that means I already have the potentiometer connected to the Arduino and we need to just connect an LED to it. So let's connect an LED to it. Uh, Now please remember when LED, where the LED is going to be connected, that is very important. So let us see, we need an LED, we need a resistance. Okay, so where do we connect it? Yes, very important. The negative part of the LED needs to be connected to the ground. Yes. But the positive part of the LED is going to be connected somewhere else. Is going to connect because now the output from the Arduino is going to come from one of these pins. So which pin are we going to use? Are we using an analog or a digital output now? Because the input is analog and it is going to be processed as analog on the other side as an output. So we are going to use, for analog, we use one of the PWM pins. Let's use pin number 10 and let's connect pin number 10 to it. So we'll make this as black because this is ground and make this as red because this is positive. So the connections are done. Why did I use pin number 10? Why? Because we are taking a PWM output from here. We will now learn few other things also. Let's stop the serial monitor here. Alright. Now we are not going to display things onto the serial monitor, or let it be. Let it be displayed on the serial monitor also. And we are going to put this output onto the pin number 10. So we need to specify a pin, a variable for that pin also. Let's make it as LED pin, and LED pin is pin number 10. We need to tell the computer that pin number 10, that is LED pin, is an output pin. Okay, specified, no problem. Now, after taking input from the from the pot pin, we are going to use pin number 10 to write that information onto the LED. So that means the output will go from 10 to the LED. Yes. So the input taken from the potentiometer has been stored in a variable called var. Let us try writing it onto the LED. So how do we write? So we say analog write, and in brackets. Where am I going to write? I'm going to write into LED pin. What am I going to write? I'm going to write the value of var. So whatever has been taken from pot pin is being written onto LED pin. Okay. As far as the basic programming is concerned, this should do. Okay. We will consider problems a little later. Okay. So let us run this program and see how things are happening. So at the moment, is the program is running and it is on maximum. If I bring it down to the minimum, you can see the brightness decreases to the minimum. If I bring it a little more, I mean little to the positive side, it will be the brightness will increase, and here is the maximum brightness. Anyway, this simulation doesn't actually show proper brightness, but still. Uh, Now there is some problem here. Let's see uh, on the serial monitor, because serial monitor is also working. Now serial monitor, here is the value of 0. So LED is actually getting a value of 0 because this is what is being input by the potentiometer. So when we go on ahead like this, the LED is now getting the value of 511. Now let us consider what inputs are being taken. The input that is being taken is actually, let me stop the simulation, is actually value from 0 to 1023. But when we write onto the digital PWM pins, the PWM pins, although they are analog, but they consider values from 0 to 255. So there is now a difference between the input and the output. Input is being taken from 0 to 1023, whereas the LED pin, that is pin number 10, is only concerned with value 0 to 255. So beyond 255 is useless for the LED pin. Now, don't you think we actually need to convert these values? For example, if it is a value of 0, it should be translated to a 0. If it is a value of 512, it should be translated to around 126 or so, 255, 127 or so. And if it is 1023, it should be translated to 255. You can see what is happening here. The translation, there must be some translation that should happen between this particular pin and this particular pin. Because this pin, the second pin, that is pin number 10, cannot take values more than 255. So we need to translate the values taken from the analog pin to the digital pin. How do we translate that? We'll consider that first. Now what we'll do is we'll create another variable. I'll create, say, var1. So I'll say var out, okay, is equal to, we will use a function called map function. I'll explain this map function to you. The map function, what it does is it takes a variable, that is var, which is supposed to be translated from 0 to 1023 to 0 to 255. So you can understand what is happening here. What is happening here is that the map function is basically taking a value from var, and the var's value are supposed to be 0 to 1023. It is to be translated to 0 to 255. So that means if var has a value of 0, it will be 0 on the other hand. That means var out will be 0. But if var had been 512, if var had been 512, it will be translated to 127 because that is halfway between 0 and 255. And if var was 1023, it will be translated to a 255. I hope that makes sense to you. What I'll do now is I will display both on the serial monitor. You will understand it better. So I'll use var out to be displayed also, and there's a delay of 500. Okay. So we have written and we have created a variable in between called called var out, and naturally var out is something which we need to write onto LED pin now. So we have taken input from pot pin in the form of a variable called var. Var is translated into from 0 to 1023 as 0 to 255. Var out will have possible values as 0 to 255 only, and that is what we are going to write onto the PWM pin, that is the LED pin. We just run this and see what happens. We can see that our just a second, serial, spelling is incorrect. All right, let's start. You can see that the Viper is in the middle of the is in the middle. So you can see both the values are being displayed. The input, that is 511, and the output, that is 127. Let me decrease this to 1/4. 1/4 is 164, and it has been translated to 40. Let me bring it to 0. Both of them are 0. All right. Let me break it to 1023. it has been translated to a 255. So you can see what is happening here. So the translation is happening from 0 to 1023 as 0 to 255. Okay. I hope this is very clear to you. Uh, Let us see the running of the sorry. Let me see the running of the program as on the LED also, because we did not actually see the LED. So when it is 0, the LED is totally off. So when it is here, the LED is halfway bright, and when we go beyond this, it is fully bright. Okay. Okay. So I hope this is very clear to you, and we'll meet in the next video.